Okay, so this would be day 6. We took an assessment, did pretty well overall. We allow students to, after they check it, to take it again. Yeah, they can do that the next day or the following day, Wednesday or Thursday in this particular situation. NMAP, we turned on the peer review part for NMAP, so the students can divide this up. The students can go back in and see what the other students did. We have like half the students have their Palo Alto accounts ready to go, so everybody needs those ready by tomorrow. AWS, if you don't have an account, you need to check back in the emails. I sent you access to the AWS course, the Canvas course. You have to make a new Canvas login separate from any of the other Canvas logins, and then you have to set that up and start looking through the materials. We're going to talk about those as we move along. Linux secure environment. We want to apply those securities. So we're working on a couple different policies: password policy, acceptable use policy. Haven't talked a whole lot about specific language in terms of how you're writing those, but we did look at SANS, and if you go to their resources, there's a policy project, and they give you a lot of templates, and you could follow one of those templates. We took a look at our environment. We have this switch, which is off one of the two DMZs off the firewall. The firewall then connects to a device that gets us out to the internet. Just an FYI, we did a VPN. Whoa! Let me see if I can get rid of that in there. VPN demo where let me use another color. Can you believe this? Let me get this. So I connected into the college, and we could communicate back and forth from home. And I showed that that is not a split tunnel. So when I went into the college, and if I went to the internet, I went from the college out to the internet. Okay, we'll discuss that more as we move through the courses. Also, off the firewall, we have the main part of the IT area, okay, which is separate from this. Okay, we talked a little bit about accessing that access point. You know, can we connect to a Telnet SSH? We talked about the traffic, not classified as anything crucial, so security there wouldn't be as high, and so forth. I also overemphasize who would classify data. Well, it'd be a combination of people, and when you get into issues of trying to decide, you better make sure you contact your lawyers for the company to decide on how you are going to manage this, if there would be a breach, and there would be lawsuits and so forth. Okay, so then in the project, each group has a PC set up like a server. So we circle these three. In fact, this will be, let's do it in blue. How about green? Okay, so we have each of these set up. I got a blue one, a red one, and a black one. And so they're setting up locations so people from the other groups can store files in there. Okay, so they'd have their two different places for the other groups. Everybody should be able to log in and out of these servers just as users. And then our goal is to create a secured environment where people can share data here, and certain people can see certain data, and maybe even build some separate accounts. Maybe they'll build an admin account that can just do, maybe change passwords and a couple things like that. So we're going to talk about a lot of security stuff trying to apply what we're learning to this environment. Okay, that went way longer than it should have. Here we go. This whiteboard review will be a little longer than normal. Data integrity. We can use a hash. Input any length. One-way hash. We get a fixed length out. Okay? We talked about we can use that to verify digital media, like, you know, to make sure one thing is transported to another place, it hasn't changed. A big area is in forensics. We can clone the media and use some type of hash to verify that clone. And we use it with passwords. We can hash passwords, and then when somebody logs in, they type the password, it gets hashed, and we see if there's a match. To make that more secure, we can create a salt, a random number, use some random generator that will create a random number to put with your password, so you store them both. So then when somebody types the password, it has to combine the salt when it hashes it to check. Talked a little bit about cracking, lookup tables, reverse lookup, rainbow tables, the 1,000 most used passwords. Yeah, you can use brute force. Somehow you have to use a hash of something you already know and see if it matches the hash of the password. So you have to try a lot of combinations. We are not doing any labs with that, but you surely could on your own if you wanted to. We did some research on the algorithms. We figured out MD5 works good for a lot of things like checking media, maybe cloning. You could use it for passwords in some situations, but if you're hashing, using hash for information being transmitted, and you want to secure it in terms of cryptography ideas, you're going to use SHA. And there's levels, SHA 1, 2, and now 3. So then we talked about media. No, actually we talked about some information here that has to do with message authentication code. Right? Message authentication code. We can do a hashed message authentication code. We can combine a key with the hash, where not only are taking care of data integrity, we're also proving who we're authenticating the information that's being sent. So we can use that idea to create digital signatures. Authenticate who it is, and take the integrity of the data, and then prove that you can't disavow or repudiate the fact that the message was sent or the message was received. We went through this little process. So I got a message. Okay, so I'm going to send the message to this person over here. Then I can hash the message and encrypt it with my private key. Send that information over. On the other end, they've got this digital signature. They can decrypt it with the public key, right? You have to share the public key, or it needs to be shared with a digital certificate. So when they decrypt it, they'll have a hash. They'll hash the message using the same hashing algorithm, let's say SHA with 256 or whatever it might be, and they can compare them. If they're equal, if they match, it had to come from this person, plus the message didn't change. What kind of algorithms we use for digital signatures? RSA, DSA, and elliptical curve digital signature algorithm, something like that. These are the three guys, Ryhurst, Simrikai, and Ullman, and this is digital signature algorithm, I believe. Now, we can take this whole idea and create digital certificates. We can have a digital certificate authority, okay, certificate authority, a CA, we can prove, okay, so we've got, you could either use a key pair you created, or you can have them create the key pair, send it to a certificate authority. They'll want some more information to prove who you are. You might actually have to drive somewhere and visit with some people and get interviewed, or depending on what level of security you want, then they'll send you back a certificate that you can use then. Okay, you can use that certificate. And that certificate would have that public key. Alright, so I gave the example like a driver's license. So we reviewed the concept, digital signature, certificate, CA. There's a root CA and then levels underneath, and then from there you would get your certificate. They talk about the certificate path. Okay, we said you could create your own certificate authority, and you could use their software. You could use probably open source software, or you could write your own scenario. We should look at that just for fun. And then public key infrastructure, right? We can exchanging these public keys through certificates, so that you can get a certificate from a website. It has their public key. You use that to encrypt, so when it gets on their end, they have a private key where they can decrypt it, and you can set up this communication. These certificates would have a lifetime, you know, I don't know, a couple weeks, a couple months, depends. But you can see how important it is then to manage the keys, especially those private keys. To wrap up, we talked about databases, specifically relational database management systems. Database is how we manage data. There's some good examples in AWS, different types of managing data. So what we're looking at though is SQL. We'll look at some more specific examples, but one of the things you have tables, like a student table, student ID, a unique. We talk about entities. We have 3 entities here. A lot of times entities, they'll call them tables. We have students, we have which term it is, and which courses they're taking, or which courses are available. And so an entity has attributes, and these attributes, okay, have to define the entity. They can't be an attribute of something else. So each attribute has to, in some way, define the entity. More on that when we take actually the database course. So we have a primary key. I did those in red. Okay. And then we can use primary keys to become foreign keys in another table, and we build this relationship. Okay, to this table and this table. So entity integrity. Excuse me. Okay, we have to be able to define each record in an entity with a primary key. We have a domain integrity. These records have to come, you know, the information has to come from a certain domain, okay, a certain group. For example, this has to come from this down here. Referential integrity would be the idea if we were to delete a course from here, all the records related to that course would have to be deleted there, because we have referential integrity between there, if it's set up that way. User defined, you know, we specifically, certain fields can have certain integrity checks in order to make sure the data is validated using data types. We can have ranges, we can have data that we can't enter, that wouldn't be accurate. We can know in range. These things can be coded, and a whole lot of work is done at the level of when you put the data in, making sure it's as accurate as it can be. You can check it before it's actually put in the database. And that is it.